And we are live. Hopefully. Just trying to bring out the chat and I'll explain what we're doing today or in the stream. Hopefully. Hey, what's up, guys? All right, so I got the chat now and I'll explain what we're going to do. So, I don't know if you guys have seen about, there's been a lot of people posting about it on LinkedIn and Twitter and so on. About, maybe we can go to LinkedIn. It was Jan LeCun. I guess he posts a lot, maybe. There we go. Okay, so we have, I don't know about this, all right? So this is what we're going to try to learn about today, which is this llama, and it was this ChatLLaMA as well, which is the first open source ChatGPT like training process based on llama using reinforcement learning. So this is on Hugging Face, I believe. Or no, it's not. It's something else. And they are supposedly a lot faster than ChatGPT as well. So we will check this out and see how it works. Nice to see a lot of people in the chat as well, and welcome. And what's up, Anai? Thanks for joining this stream. All right, let's see. Here we go. We introduce LLaMA, a collection of foundation language models ranging from 7 billion to 65 billion parameters. We train our models on trillions of tokens and show that it is possible to train state-of-the-art models using publicly available data sets without resorting to proprietary data sets. Oh, okay, this in particular, LLaMA 13b outperforms GPT-3 on most benchmarks, and LLaMA 65b is competitive with the best models. We release all models to the research community. I wonder if this is with the weights included as well. All right, so it stands for LLaMA. Okay, I actually thought it would be something including, like it would, but it's like open and efficient foundation language models. And I don't know if you guys have seen what Yannick is working on as well. What is it? Open Assistant. I guess it's kind of similar thing, kind of. But maybe they got beat to it. I don't know. Or I guess it's still. I have no idea what we're gonna need for this actually. I have not looked at the paper, and so that's, I think what we're gonna do is we're gonna just check how it works and try to understand what this is basically. Maybe it would be cool to understand this ChatLLaMA as well. Please note that this code represents the algorithmic implementation for RLHF. So what is that? What does that stand for? Reinforcement learning, human feedback. Okay. Yeah, that's sort of the ChatGPT training, right? So ChatGPT training was collect data. First of all, we use sort of sort of a standard training, right? So we do a prompt. Okay, so we have, all right, so wait, we collect demonstration data, a prompt, a labeler demonstrates the desired behavior, This data is used to fine-tune GPT 3.5. All right, so we have GPT-3, right? And then we fine-tune with this prompt and labeler. And then we collect comparison data. So we have a lot of prompt answers, and we rank them from best to worst. And so this is what a labeler does. And then we use this to train a reward model. So basically, I don't know what the difference is between, to me, right? This is kind of like a GAN architecture almost, because sort of what I think as being the fundamental of GANs is the loss function, right? That's really what the contribution was of GANs. I consider that to be the sort of the effect of it, right? We know that like there are different types of loss functions, and the best loss function is like make it indistinguishable from what a human produces, right? And so here they are basically making a reward model that says, all right, this is good and this is bad, and then they train it with a reinforcement learning algorithm to output, good according to the reward model. So I guess, what is this actually about then? So, this is not actually that much, right? So I wonder, hugging face. No, I guess it's not on hugging face, but it will be soon, maybe. Because this is kind of HF like tokenizer. All right, so you said I see the reward model as make it usable. Can you elaborate what you mean by usable? Like what would you say is the difference, right, between a GANs and this? So if you're optimizing towards a loss function, that is basically that's the discriminator, right? And then we use in this case we use a PPO model, so it generates that output, and then we calculate a reward based on the reward model, and then we optimize towards this reward. How is that different, sort of from I guess it's the PPO algorithm, right? But then I guess it's how you view it, maybe. I'm not sure. All right, we downloaded the paper here, and we'll open this with Drawboard. That's what I like to use for PDF annotation. Oh, what is it? PPO model? PPO, what does it stand for? It's a reinforcement learning algorithm. Isn't the reward model a simple dense network? Yeah, I agree. So okay, PPO model. I mean, this is the PPO model is a sort of just a reinforcement learning algorithm. Isn't the reward model a simple dense network? I don't know how they structured the reward model, but like fundamentally, it's a model that knows what a good answer is and a bad answer. It must be based on some type of transformer, because it needs to understand what is good and what is bad, right? And the PPO model isn't the LLM. So the PPO model is just, from my understanding, okay, is just a reinforcement learning algorithm they use to optimize the language model. Yeah, the reward model is another transformer, because it needs to be good, right? It fundamentally needs to understand what is a good text and what is a bad text, or a good answer and a bad answer. But I guess it's easier, right? It's easier to distinguish between knowing that this is a good answer and a bad than than generating the text in the first place. But I would still argue, unless you have a argument, that this is more, this is like this is GANs, I would say. PPO is like Atom for reinforcement learning. I guess you. I mean, not. Right. What does it stand for? Proximal policy optimization. I read about this a long time ago. Let me see. New class of reinforcement learning algorithm, which compare. I think it's like a simpler one, right? It doesn't have as much. It's simpler to implement. It's a proximal policy. I don't know if it's like on policy or off policy or how it works, but it's like a really popular. Hey, on policy. All right. All right, so at a high level, PPO works by iteratively improving a policy that maps an agent's observations to actions. It does this by collecting experience in the form of trajectories, and then uses these trajectories to update the policy. All right. So let's go to the paper, right? This one, and let's see if my thing works. Nice. All right. All right. Open and efficient foundation language models. We introduced LLaMA, a collection of foundation language models ranging from 7 billion to 65. So I hope they actually release this. I don't know. I guess they'll tell us. We train our models on trillions of tokens and we train our models on trillions of tokens and show that it's possible to train state-of-the-art models using publicly available data sets. I think they said something in this paper that their training was 15 times more efficient than ChatGPT's training. So I wonder. So, right? Okay, so I'll just tell you, like, now I have no idea what this is. Like, I'm trying to figure it out, and we're trying to figure out how this works sort of live, right? So when I'm reading a paper, generally I like to just get like an overview first, and then we try to sort of converge on specifics. So first, I'm just trying to figure out, like, what is this actually, like, in what scope is this trying? What is it trying to solve? So to me, this is like they're trying to make ChatGPT, but actually, I don't know. So they're trying to do ChatGPT, right? But they're training it. All right. So I guess, right, the thing is here, right? ChatGPT has proprietary data sets, right? So this one is trying to do ChatGPT, but public. So it's kind of like Open Assistant that Yannick is doing, but sort of a similar thing, right? All right. So that's what they're trying to do. That's sort of my understanding. but I also saw that they argued that it was a lot better. But let me put on some, I don't know. I don't know if it's actually nice or not, but sometimes I like having some type of background music. Just want to make sure it's not too loud. Just something that's in the background is nice. All right, so let us see. So if we just scroll through it, first of all, they have an introduction, LLMs. I think they must mention ChatGPT somewhere, right? But I guess they're trying to do smaller ones as well. So a big component of this is that they're trying to do a smaller one. A smaller one trained longer will ultimately be cheaper. And they're only training on publicly available data, making our work compatible with open source, right? This is a huge component. In the rest of this paper, we present an overview of the modifications we made to the transformer architecture, as well as our training method. LLM. Okay. LLM, I guess, yeah, is for maybe large language. I don't know why they named it LLaMA. Do you know? Large language. I don't know. First, I was like, it would make sense if they like mapped. Usually, they have like the first is the first word, right? But here it's, I don't know. All right, so they let's see, they have the approach. Then they have the data sets here. So they have a lot of Common Crawl is the largest one. C4, GitHub. Oh, damn, that's a lot of GitHub, Wikipedia, books. Imagine just how large of a text this is. If you have 3.3 terabytes, it's an insane amount of data. Wonder how long it would take to read this. That would be a... All right, so they talk about the data sets here, pre-training on data sets, and they have the parameters of the model, 6.7. Man, I hope they have weights with this because it would be so fun to play around with sort of this model. Hey, guys, you see the learning rate? 3E minus 4, baby. That's probably why they got good results. Batch size of 4 million. Must have been, I wonder how they trained this. I hope they go into that as well. All right, so here's the architecture. They have some different type of components here. All right, this is interesting. I haven't actually taken a look at anything sort of how they, what the training looks like right now for transformers, sort of how it's different from the vanilla transformer. And what is this? All right, so zero shot performance. And then we see that, all right, so they said that, right, the 65 billion is better than GPT-3, which is interesting. All right, that's interesting. And then what do they do else? Closed book question answering. 2 closed book question answering benchmarks. All right, so another benchmark here. Mathematical reasoning. Isn't it interesting that language model is good at pretty much anything, but it sucks at math? Code generation. All right, so they have a bunch of evaluation. So really it's not, I mean, all they did here, right, is what is the actual contribution of this paper, would you say? Because they basically just sort of collected and gathered sort of instructgpt, right, the RLHF, reinforcement learning human feedback training, and use it on public data set, right? So the training is really what is their contribution here, right? It's nothing novel, basically. It's just this instruction fine-tuning kind of. And then they have a bunch of other ones as well. There's a lot of different metrics. So they have one specific to bias as well. Toxicity prompt, gender something, truthful QA. All right, let's see what their conclusion is. So in this paper, we present a series of language models that are released openly and competitive with state-of-the-art foundation models. Most notably, LLaMA 13b. Wait. So LLaMA 13b outperforms GPT-3 while being more than 10 times smaller. I think I can run a 13 billion model probably on inference, maybe on my computer. Imagine having a GP3 local and then you're able to sort of rent a cluster, fine tune it on a specific data set that's sort of specific to you, and then have it being able to run that locally. Isn't that, to me, that's actually insane. Dr. Merlet, I don't understand what specifically, because I don't understand either. There's a lot of stuff. Yeah, so this is their contribution, right? This is basically, they have more compact models, and unlike previous studies, we show that it's possible to achieve state-of-the-art performance by training exclusively on publicly available data without resorting to proprietary. Maybe we can take a look at, have you guys taken a look at ChatGPT paper? I guess maybe, I have actually not. It would be interesting to just see, is it just this blog post or? I mean, this instructgpt, I have taken a look at, seems a bit complex. Well, actually, I mean, there's nothing really new in this paper. I mean, yeah, it would be nice to have a figure, but they haven't really done anything. I think that's why they didn't feel, I mean, they did some modifications, but the huge component here is it's actually the push towards open source, and if they release the weights as well, I guess that's this chat. The first open source implementation that leverages, so this is the first that uses this. Yeah, okay, so you have the pre-trained LLaMA models, and then this is the first one. I guess Hugging Face will come with one. I can only imagine it will be in the upcoming weeks, probably. And then we can fine-tune our own. That would be pretty cool, right? All right, so Meta has recently released Llama. We know about that. 13B outperforms GPT-3, yes. And then this is from OpenAI's blog. Does anyone know if ChatGPT was actually a paper or was it just a blog post? I know it's based on this instructgpt, and so it's sort of just an application of that, but did it actually come with its own paper, or was it just sort of deployed? Because then it's also interesting with this llama that it has like the actual evaluation on multiple data sets. Maybe we can take a look at that instruct. Yeah, ChatGPT didn't come. If they already trained it, let's load up some weights. Maybe we can try and run it on the stream. I don't know. Let's see if we can. I don't know. What do you guys think? Should we maybe go? Where do you guys want to take this? So we can either take a deeper look on this paper here, right? We can look at the implementation a bit more. Or we can also go into an instructgpt paper, which is sort of what ChatGPT was based on. Maybe we get some further details. What do you guys think? InstructGPT. We can take, I mean, first, let's just go through it quickly. Making language models bigger does not inherently make them better. I mean, if you guys have played around with like ChatGPT and GPT-3, it's incredible at just like how much easier it is to use ChatGPT. Like the prompting is just so much more intuitive and it just works a lot better because of that reason. For example, large language models can generate output. Let's see. Making language does not inherently make them better. Well, it does too, right? But I guess it's not the only factor. For example, large language models can generate output that are untruthful, toxic, or simply not helpful. Right. Okay. I understand what they are saying here. That's true. In other words, these models are not aligned. And that's true. But in many, so ChatGPT is still not really aligned, I would say, right? I mean, one of the biggest problems with ChatGPT or language models in general is that they just make things up. So I don't know if you guys have noticed, but especially if you use ChatGPT for like programming, you're like, hey, I want to do this, and it gives you sort of a library to use maybe, and then it will use a specific function of that library, and it will use arguments that it doesn't even have. So like you try to run it, and then it says like this argument doesn't exist, and so you basically tell it, hey, by the way, it doesn't exist, this argument. He's like, yeah, sorry about that. It was available in a future version, but I guess you don't have it, so you can try this. And sort of, I have the latest version, so it's just making shit up. Like it's I don't know, it's just lying to you. So in many ways, it's still not aligned, but it's more aligned, I guess. In this paper, we show an avenue for aligning language model user intent. I wonder sort of how broad by fine-tuning with human feedback is, and how much data you need that's human feedback. Because I mean, one of the really strong things about language models is you can just take text and sort of run it, because it's just a next word prediction algorithm, right? Or model. It just predicts the next word. But then if you take human feedback into consideration, you need to also have a huge labeled data set on that, and that might be very expensive. So wait, how did wait, so that brings a question. How did Llama do that, right? Our training dataset is a mixture of several sources that cover a diverse set of documents. We reuse data sources that have been leveraged to train other LLMs with the restriction of only using data that is publicly available. I don't know if I understand how they did the data here, because there is no uh, where's the human feedback part? Because this is just the data. I mean, this is just for pre-training. ChatGPT doesn't require much data from human feedback. Yannick said in one of his videos that he just needs a couple thousand data points. Really? That's not a lot then. I wonder if you also hmm. All right, but they must have still had the data set, so I'm just trying to scan for data set. I don't know if I've missed it. There we go. Instruction fine-tuning. We showed that briefly fine-tuning on instruction data rapidly leads to improvements. Okay, that's what you mentioned as well. Although the non-fine-tuned version is already able to follow basic instructions, we observed that a very small amount of fine-tuning improves the performance on MMLU. What is MMLU? MMLU. All right. MMLU. I don't know. Is it instruction fine-tuning? MMLU 5-shot. Okay, it's data set, I guess. We can maybe take a look at MMLU dataset. MMLU dataset. It is a new benchmark designed to measure knowledge acquired during pre-training by evaluating models exclusively in zero-shot and few-shot setting. This makes the benchmark more challenging, more similar to how we evaluate humans. 57 subjects across STEM, humanities, etc. They haven't added llama here yet. Okay, so let's see what they got. Here they have chinchilla is better. No, okay, you got 68. I don't know what the difference is here. Oh, this is the that wasn't fine-tuned. Okay. With and without instruction fine-tuning. Massive multitask language understanding. It would be nice to have just an example of the data set. Yeah, I don't know what it's saying here. I don't know, man. To me, it seems like memorization of answers. What do you mean? Because, I mean, if we go, I mean, probably, but it's probably done like a really good compression of data, but it does have, you know, unique answers as well. So it's not, you know, strictly memorization. Otherwise, it wouldn't be, even if it is memorization, it would still be useful, right? But yeah, it's definitely not sentient, right? Or I don't know. It's, I mean, like, it's obviously that there are major sort of things to take into consideration for that. Is ChatGPT Plus worth the $20? I don't know. I actually, I haven't decided on that. I think like honestly, like if you're asking me, the biggest pro is that you can just do like, I can just do AI. I mean, you can do that anyways, but it's never gonna ask you to verify and shit. I think for me, that always wasted a lot of time. Just, uh, it saves your logging, and so you don't have to. You're instantly verified and can just use it. Honestly, that's the biggest pro. If you use Bing rather than ChatGPT, you get more up to date. Yeah, I'll look at that. I haven't checked that. All right. So, anyways, all right. So, although the non-fine-tuned, etc. Since this is not the focus of this paper, although the non-fine-tuned version is already able to basic follow, we observe that a very small amount improves the performance. Further improves the ability of the model to follow instruction. It says, since this is not the focus of this paper, we only conduct a single experiment to entrain an instruct model. So wait, what is the or sort of what was the, I'm confused, guys. Like, what is the data? Or, I mean, okay, so you don't have to do a lot of fine tuning. We show that briefly fine tuning on instructions data rapidly leads to improvement. But so where is the, where's the instruction data set then? It's probably me that's missing. All right, we only skimmed the paper, but. All right, let's go to the other one as well, the instructgpt. In this paper, we show an avenue for aligning language model with a user intent on a wide range of tasks by fine-tuning with human feedback. Starting with a set of labeler written prompts. Oh, and prompts submitted through the OpenAI API. We collect the data set of delivered demonstration of the desired model behavior. Okay, in human evaluation, outputs from the 1.3 billion parameter are preferred over the 175 billion. All right, that's interesting. And then if we do the same thing, all right, let's just skim it first. We win rate against SFT. All right, so here we see that PPO PTX has the highest win rate. And this is SFT. Human evaluations of various models. Cool. All right, so this is the figure we've seen many times. Laborers significantly prefer instructgpt. Instructgpt models show improvement. Instructgpt shows small improvements. We can minimize performance regression by modifying. Okay. All right, so they mix PPO updates with updates that increase the log likelihood. So that's a PPO PTX. Public NLP data is not reflective of how our language models are used. So they're not aligned in that way. All right, so they have related work here. All right, so then they have distribution of case categories. So most of the time you just want generation. You want question answering, then 12%, brainstorming 11%, chat 8%, rewrite 6%, 4% summarization, 3% classification. Okay. All right, so our prompt dataset consists primarily of text prompts submitted to the OpenAI API, specifically those using an earlier version of the InstructGPT models. So this is where the dataset comes in, right? Being proprietary. We ask labelers to write 3 kinds of prompts. Plain, we simply ask the labelers to come up with an arbitrary task. Few shot and user-based. All right, so they created SFT models. The SFT data contains about 13,000 training prompts from the API and labeler written. The RM has 33K training prompts, and PPO data has 31K only from the API. Yeah, so I mean that's compared to what it's been trained on originally. That's not that much, right? But it is. Yeah, actually, it's not that much in comparison. Supervised fine-tuning. Oh, that's what SFT. I was like, what's SFT? Supervised fine-tuning. We fine-tuned GPT-3 on our labeler demonstration. Okay, and then they reward modeling okay, starting from the SFT model with the final unembedding layer removed. Oh, wait, so the reward model is actually GPT-3 as well. Starting from the SFT model with the final unembedding layer removed, we trained a model to take in a prompt and a response and output a scalar reward. In this paper, we only use 6 billion RMs, as it saves a lot of compute. All right. So wait, is the reward model, is it fixed? Like, is it frozen? No, it needs to be trained, right? Yeah, so it's GAN, no? It's similar to GANs. I know this is like old research, but whatever. I haven't read this. But it is not, like, if you're using how is it different? You have a generator and you have a reward model that's a discriminator to say what's good and bad, and then you're optimizing it using some type of algorithm. That's a GAN loss to me. If you are sort of right, it's you are wanting to trick the reward model into thinking that your generation is actually the real one. I don't know. You let me know where you think I am wrong in this. Isn't a transformer with a regression head? I need to take a look at that again. I don't know which layer they actually remove here. The final I mean, what do you mean by a regression head, by the way? I mean, here you're running it through, right? With the entire, and then you're wanting to predict a single output. But instead of doing a one word, I guess they remove this linear layer that maps into the actual word. And so you just take this and you could swap the linear layer to sort of a 0-1 prediction of it. If it's, I actually don't know exactly. Oh, what happened now? Exactly how they did that, but sort of similar to GAN if it's real or not, and then optimize it. All right, specific to the loss function for the reward model is this thing. All right, so they have a scalar here to, depending on how many responses there are. Then we take the expected value of the data set of human comparisons. We take the reward model on the generated so why is the, okay, why oh, okay, right, this is only for training the reward model, so they're only doing this is the preferred one, and this is the other human labeled prompt or prompt answer. All right, and here's the PPO algorithm loss function, and then they also add PTX for the likelihood. I think if we would take a look at this, it would probably be All right, we don't have to go into reward model is ranking the prompt. I mean, we already have it ranked, right? We have it ranked already because of labelers. And then here the reward model is learning how it should rank them. I don't know exactly how they prompt or how they train it though. Like what is the input and output in this case? Or how do they structure the input and output? I mean, this is, so I guess here you just send in the prompt and you send in the completion and you get a reward for that. And then you have a preferred one and then you have a less preferred one. I don't know why it's W. I don't know. Winner and loser? I don't know. The winning answer, we want that to be a higher reward than this. And so we want here what is this sigmoid? We don't have to go into the absolute details of it's cross entropy loss. We don't have to go into the, but I mean, like this reward should be larger than this one because it's less preferred. And so later on, right, we're gonna rank it because after reward model has been trained, we can input anything and it will re-rank it, or we can re-rank it, right? So it's sort of labeling its own examples after that point. Maybe, that's interesting, yeah. Is that similar to, I mean, it's sort of in a way similar to semi-supervised learning, I guess. I mean, it is semi-supervised learning, right? I mean, if we use a small instruct data set that we have, we train this reward model, and then we can utilize this insane amount of prompts that it can generate, and then we can continue training it for a really, really long time because we have the reward model. All right, that's cool. And then, I mean, the only thing I'm wondering is the data set in this LLaMA paper. Introduction. Large language models trained on massive corpora of text have shown their ability to blah, blah, blah. Unlike the other ones, right? Let's not bash them, but unlike the other ones, we are a lot better and we use publicly available data, and therefore we are open source compatible. Other rely on data which is either not publicly or undocumented. In the rest of this, we present an overview of the modifications to the transformer. Our training dataset is a mixture of several sources. All right. Guys, it would be cool actually if we could use this. How many viewers do we have, by the way? I'm curious. It says 1 watching. Guess not that many. Oh, 30 watching. Holy shit, that's a lot of people. I shouldn't have looked at that. All right, but let's see if we can actually like use this. It would be cool to run it, but can you actually run it here? Because this is sort of the training, right? But llama GitHub inference code for llama models. I feel like they should be linking to GitHub here somewhere. Facebook research. Here it is. Okay, this was the one that we used. Different using different MP values. Torch run. Oh, you need to have this repository intended as a minimal hackable and readable example. Fill in this Google form. All right, let me fill this out and let's see if we can get access to it. That would be nice. All right, I accept this above. Submit. All right, and then I wonder how long it will take. Is it instant or? I guess we'll just wait and find out sometime. Cool. All right, so after we get access to that, we are going to be able to download. Guess it will take a little bit of time maybe until it's available. Yeah, you have to complete a Google form. Yeah, I mean, that's yeah, I mean, I don't know, like, how did they evaluate if you can obtain the weights or not? But then afterwards we can run it. I mean, that would be pretty cool if we could actually run it. Maybe if I get access to the weights, we can do that on another stream and we can see how good it actually is. And also this ChatLLaMA thing would be cool. And I think I'll wait until we have a Hugging Face part, to be honest. But this seems relatively nice to use, right? It seems pretty simple. Still unclear what data they use. That's the part I want to figure out for the instruction part. I mean, they say that it's not part of their actual What was it that I wanted to see now? Ooh, I wanted to see the post they made, because they said something that it was a lot more efficient. Meta AI just released LLaMA, collection of foundational large language range from 7 to 65, is creating a lot of excitement because it is smaller but has better performance on specific tasks. The new collection of fundamental models opens the door to faster inference, being cost efficient running on a single GPU. However, LLaMA was not fine-tuned for instruction tasks with reinforcement learning. Oh, okay. However, okay, they did not focus on that. Okay. All right, then okay, I just got it confused then. Then I understand. All right, so that's what they tried to do, basically. They did do it in the paper, but it wasn't the focus. Okay, so I hope, all right, so this is actually a good contribution on their part then. Please note that this code represents the algorithmic implementation and does not contain the model weights. You need to apply to Meta's form. What do you guys think? Do you think I will get access to the weights? If we do get access, yeah, I'm not in the PhD club. Wait, how old are you? I am 25. Like, are you on campus for undergrad and masters? I'm currently doing my thesis. I'm not a theoretical physics PhD. He's trolling you. I'm not a theoretical physics PhD. Sorry to unimpress you. All right. All right. So, all right. All right. So I think honestly, we did get a good overview. Like, how would we? I mean, we didn't do that long of a stream, and we can obviously take a much deeper look at it. But for 1 hour, I think we got a pretty good understanding. Let me see where. Oh no, I actually closed the chat now. So let's summarize just to like our understanding from this hour. Obviously, take a much. All right, so. All right, so. What did? Okay, so. LLaMA is just an open source GPT. That's it. It didn't focus on the instructgpt part, although they did that. It's not part of the code and so on. It's just inference. And all they wanted to do is that it's possible to train on state-of-the-art models using publicly available data sets. So it's a push towards open source and making these models more efficient and just sort of make it open source. What confused me and why I thought it was using this instruction part was that they tried to make it a lot more efficient, right? That's why I thought they used instruct. I don't know how they were able, using a similar training process as GPT-3, how were they able to make it? How did they make it more competitive or sort of outperform GPT-3 on most benchmarks? Is it because they had more data available, or let me know if anybody has a thought on this. How could they only use open source data and then outperform it while being 10% smaller? and that's without using the instruction part. So that's a little bit confusing to me. That's why I thought they were combined. But then this ChatLLaMA that I saw on LinkedIn that I was curious about was they actually included the training part to use this. But then we have to access the weights, and we filled out the form. Hopefully we can get that, and then we can make a continued stream, and then we can see, you know, how does it compare to ChatGPT, and so on. Let me know, like, what do you guys think? Should we be happy with this overview, or should we do you want to because I am getting a bit hungry, maybe I should go eat something. Honestly, like the only idea with the stream was to get an overview of LLaMA, and I think we have gotten an overview, and I'm not sure if it's worth digging into the absolute details of it, honestly. What do you guys think? What do you want to focus on? Personally, I would have liked to try it out right now, but we don't have the weight. So what we could do now is we could dig into, I mean, we could understand how they did it with the architecture and all of this stuff, but I'm not that excited for it, to be honest. I would rather just, I mean, I can understand the overview. I would like to build something on it. I would like to have the weights. I would like to generate some type of data set. I would like to fine tune it and just understand the details, and then we could refer to the paper. But I would much rather do something more applied. Otherwise, it just gets too sort of abstract for me. So hopefully they get us access to the weights, and then we can, or if someone knows if there's like a Pirate Bay version for the weights that we can download, and then we can play around with it. But that would be my next want and desire. I don't know, we can do like a, if anyone has questions and stuff, we can take it from the stream. All right. If nobody has any questions, I guess we'll I don't know if there's I mean there's a delay. I'll wait a bit if anybody has any questions, or if you have any thoughts on what like what else we could stream for future stuff. Let me know. I will continue, like my goal is we were doing a Hugging Face. I will continue with that, and the next step is to fine tune a version. We sort of did that almost, but we will do some type of project using Hugging Face. And I was thinking of just completing that with, we were doing a news article summarizer. So I was thinking we could like do that, and then we can see how to fine tune it and then the result. So that will be like a fun project to learn Hugging Face, but still do something. I have that planned for a live stream, probably this week. If not this week, probably next week. And yeah. How do you manage personal projects? How do you manage with academia? You mean like if you're a student, how do you manage doing what you want to do on your own, but you still have courses and that kind of stuff? So is it more like a time management type of thing, or? Yeah. Okay. So I would say I don't know how you do that. I think in general, for me, so in sort of my first year and sort of in the beginning of studying, I put all my focus on doing well on courses. And I think doing well on courses has value. And I think it's worthwhile to spend the time to get good at sort of knowing how to get good grades. But you sort of get the realization, or I did at least, is that grades are not actually that important. So to me, right now, I spend very little time. Actually, I don't care about my grades that much. I still I still have sort of an underlying desire to do well and understand stuff. But honestly, if I didn't get a good grade, I honestly wouldn't care that much. Unless I myself was really interested in that and tried to do my best, then I would care. And so I think, for me at least, I think the desire or the pressure and stress to do well on courses has sort of lowered a lot. And then it's more like, all right, realizing that what you're curious about and what you're motivated to do is a much better indicator and much better sort of a much better way of learning stuff and developing yourself than following someone else's structure. So to me, always sort of keeping in mind that you are your own leader or whatever, like you should listen to that person of you that is interested and curious about stuff. And so you should never try to overpower and sort of just kill all the creativity of your own self motivation because of schoolwork. With that said, right, you have to do well on courses, or you have to sort of complete courses, right? Uh, but I think having faith that following your own curiosity is the best way to go, and whatever that is, right? And you'll make mistakes, but at least you are learning on your own. You're not following someone else's only examples. I don't know if that was useful, actually. I don't know. What's your opinion on explainable AI? I don't know. I don't know. Um I'm not that good at explainable AI. I would need to read on that, actually. I would need to get up to speed on how you do that. For its speech to text application, speech to text. Do you know any Hugging Face models that perform better than Google's speech recognition API? I mean, Whisper is state of the art. Have you tried Whisper? I think it's a lot. It's probably the best right now. Don't you feel overwhelmed by the amount of new papers? Yeah, and I don't do the best job of sort of right now I just follow Twitter and follow people that and then I try my best to look at papers. I'm gonna try to improve. Um, I don't know, doing live streams like this maybe would be cool. I don't know if you guys enjoyed this. Did you guys feel like you got a better overview of Llama? I was thinking of like when there's a new paper that comes out, we can do like a quick live stream and get sort of familiar with it together, and then I could make a more refined tutorial video or paper explain video. Can we use Whisper? What is the rough estimate of your deep learning rig? It's not expensive. I don't think so. It was I bought the 3090 used, so it wasn't that expensive. I think it was like $800 maybe for one 3090. And the other thing I have is it's just a standard. I don't have that good of a CPU or anything, and it's like 32 gigabytes of RAM. It's not like a really strong machine. I need to update the RAM actually. And if you're sort of looking for what to do or what to focus on when doing a deep learning rig, Google Tim Detmers. I think I'm butchering the pronunciation. I'll just write it. Look at that guy's blog and then follow his guide on it. How did you configure your rig for SSH? I'm traveling a lot, but wanted to use my GPU remotely as well. So actually what I did, I mean, what you can do is if you want to have Windows, you can just buy a second hard drive and then install Ubuntu on that. So you have a separate one. And then if you're traveling, you can just sort of boot that one. And either you can use Ubuntu. I actually use Ubuntu server. So I just set up SSH from Ubuntu and then I can SSH into it. I actually like it a lot because it makes it possible to have multiple people working on stuff at the same time, but single server. And then obviously the flexibility of using my laptop from anywhere, and I have access to good compute. What type of projects do you think help the most of getting your job? I'm from Costa Rica trying to land an ML job. So I don't know if I have good advice on that. I think in general, you should try to document what you're doing and try to share it with other people. I think that's a motivating thing for you. And I think other people that see it, it's a good indicator of what you know and stuff. So that's my advice. So when you're learning something, document it, be that in a YouTube video, blog post, GitHub, Medium article, whatever. Just document what you're doing, and that's it. And then follow whatever you're interested in and do projects. So that's it. Really, that's it. Like, follow what you're interested in, do projects on that, and share it, and then do it. That's it. Any update on the recommendation engine you were building? Yeah. So yeah, it's like mostly now we're focused on the cold start problem for that. And actually for that, I'm going to be fine tuning. At some point, I'm going to need to fine tune a Hugging Face model. So that's sort of where the Hugging Face comes in. So I'm going to learn and do how to do fine tuning on that. And then the sort of to use the actual recommender system when we get ratings and so on will be at a future point. So it's kind of in the initial stages right now. All right, guys. I should have done this, by the way. Now we didn't see the. Should have done this. All right, but whatever. All right. Thanks for joining the stream, guys, and I hope it was useful to get an insight together on Llama. Let me know if you have any comment on this stream, if you have any like other papers we could go through. We could do that together, and it could be a chill way of getting an overview of stuff. Yeah, the used 3090s was yeah, like eBay equivalent in Sweden. All right. Bye, guys. Take care. Thanks for joining the stream. Have a good day.